Yesterday we looked at the beginning of our series unit, and we started with geometric series. This is a good series to start with because it's one you're very familiar with, but just understand that we're going to look at a lot of different types of series, and there's going to be a lot of tests that we're going to learn how to do on these different types of series that will let us know whether or not the series converges or diverges. So you want to start a list, get yourself some good notes, and make yourself just whatever little details you need in there so that you'll remember what the tests are and when to use them. So let's go ahead and review the geometric series test. You did, like I said, you looked at it yesterday, and it's a review from last year, but let's go ahead and just look at it again. It's a good place to start. All right, our geometric series test is, it regards those series that are in the form a times r to the n, where r is a common ratio, and it involves multiplication. You're going to have these exponents. It would be something like 2 to the n, or 1/5 to the n, that sort of thing. Okay, maybe it's negative 3/7 to the n. Okay, so just it's something being raised to an exponent. The series will diverge if r, your common ratio, is if the absolute value of it is greater than or equal to 1. And so this is our r. Whatever's being raised to the exponent is our r. Okay, and if that r, the absolute value of it, is less than 1, then the series will converge. And we learned last year in pre-calc that the sum of that was a sub 1, which is the first term, over r 1 minus r. Very familiar to you. So let's go ahead and look at an example. So down here, example 8, part A, we've got the infinite series n from n equals 1 to infinity of 3 over 2 to the n. And just to show you that it is a geometric series, I'm going to rewrite it in our form of a times r to the n. Okay, so those are equivalent statements there. Now, the problem is asking us, the example is asking us to determine whether the following series converge or diverge. And if it converges, find the sum. So you want to be real careful about what the answer or what the question is asking before you answer it. You don't want to just go and stick an equal sign here and come up with the sum value. You're going to need to have a conclusion whether or not it converges or diverges, and how do you know that series converges or diverges. And so you're going to end up naming the test that you're using. So you want to justify your answer when you're doing these problems. Okay, so I'm just going to sort of summarize what we have here. I know that a sub 1 is going to be 3 times 1/2, and then I'm going to be real careful to look at my problem and make sure I'm using the right beginning n value, because we could start with n equals 0, we could start with n equals 1. I mean, we could start at n equals 40 or 500 or something like that. So just be careful with that. So a sub n in this case, I'm sorry, a sub 1 in this case is just going to be 3/2. That's our first term in this series. And r, as we saw when we rewrote the problem, is 1/2. So since r is 1/2 and that happens to be less than 1, that's our test. That's our geometric series test. What is r, and is it greater than or equal to, greater than or less than 1? Because this is less than 1, then we know that the series converges. Okay, and now we're going to say what it converges to. But you want to make sure when you're writing this out that you're actually showing the part of the test that you're using to justify your answer. Okay, so what does it converge to? All right, so it's going to converge to S equals 3/2, which is a sub 1 over 1 minus r. Oops, I should actually write what r is, which is 1/2. So minus 1/2, which is 3/2 over 1/2, which is 3/2 times 2 over 1, which is going to be 3. All right, so this particular series, so therefore our series, write that a little neater, sorry, of 3 times 1/2 to the n converges to 3 by the GST. All right. You could write out geometric series tests, but it's okay for you to abbreviate this. Okay. Another thing that you could do if you wanted to is you could assign this a name, right? So you could say S sub n equals that series, and so then instead of rewriting that whole series to save time, you could just write S sub n converges to 3 by the geometric series test. So, okay. All right, so let's do another example. So here we have the sum from n equals 1 to infinity of 3/2 to the n. So here r is 3/2, and you can certainly write the absolute value of r if you want, since that technically is what is in our test up here. So the absolute value of r equals 3/2, which is greater than 1. It is not less than 1. And so this series is going to diverge because r is greater than 1. So we would say it diverges by GST. But again, you want to show that you are actually doing the test. Okay, we don't find, what it. We don't go and try to plug anything into a sum formula since it diverges, and so that's all there is to it. We can move on. All right, so in C we have the sum as n goes from 2 to infinity of 3 times negative 1/2 to the n. So here we have r that is negative 1/2. Okay, so the absolute value of r is the absolute value of negative 1/2. Okay, and that's going to equal 1/2, which is less than 1. Okay, so we're okay there, and so that automatically tells us that it converges. I'll just make a note to myself as I'm working that converges. So since it asks me to find the sum, then I'm going to go ahead and plug into the formula. So I need my a sub 1, my first term. So it's 3 times negative 1/2, and now we want to be very careful because we are not starting at n equals 1 or 2. At 1 or 0, we're starting at n equals 2. So you want to make sure you get that that little detail picked up. So it's going to be 3/4 is our first term. All right, so I'm going to just say that I'm going to let S sub n be my series. So I'm going to go ahead and find out what the sum equals, and so that's 3/4 over 1 minus 1/2. 1 minus negative 1/2. So that's 3/4 over 1 plus 1/2, which is 3/4, and this is 3/2 down here, so times 2/3, and so that's going to equal 1/2. All right, so let me scoot up a little bit so we got a little bit of room here. So S sub n converges to 1/2 by GST. So you have made your conclusion, you've shown what the sum is, you've shown all of your work, including the work involved in the test, and then you've given the test that you used. So all of that you want to have for your justification.